Okay. Now let's see level of, there is something called confidence interval. Confidence interval. All of you know about a level of significance, right? Confidence level. Okay. All of you know about level of significance. LOS in short is nothing but alpha or the error. Error, it decides the error region. Okay, all of you know about that. Now, what is this confidence interval is? Suppose if I am taking alpha is equal to 0.05, I am taking alpha is equal to 0.05. Okay. And then I am choosing a two-tail test. Two-tail test. I have explained in the previous videos when we will choose a two-tail test, when we will choose a right and a left tail test. Please go through it if you have a doubt. Suppose alpha is equal to 0.05 and HA, I have taken it to be a two-tail test. H naught is as it is. Two-tail will be something like in terms of mu not equal to some value. Okay, mu not equal to mu naught or whatever. Okay. So what do I do is, if it is a two-tail test, then Z alpha by 2 is what I will calculate. I'll just show you, please. Look here. I'll split this 0.5 into two halves because it's two-tail. Here it would be 0.25 and here it would be 0.25. Okay, on the right and the left, I have two rejection region. That's why I have two tails. Tails are the rejection regions. Now this value would be what? 0.475. Yes, right. Now I'll look for the Z value. P of 0 less than Z less than some value. Let this be Z1. This area I'm getting it to be 0.475. I'll look for this area in the table. Z tables. Okay. Now here I'll be getting Z1 to be, all of you can see, it would be 1.96. So how do I write confidence interval is, I'll be telling the confidence interval. Confidently, I'll be telling an interval for the given Z value. Okay. The formula is the same, Z only. Greater than 1.96 or Z alpha by 2 or whatever, Z alpha. Okay. So already I'll have this calculated value. So it'll be something like mod is there, na? So plus and minus I will take x bar plus or minus 1.96 sigma by root n. I'll cross multiply plus mu is what I will have. Okay. Yeah. Plus mu is what I will have. Right. So confidence interval, how I will tell is x plus or minus 9.6 by root n. If suppose if I have x bar is equal to 40, sigma is equal to 10 and n is equal to some 400. So how will my confidence interval be? Just see here, guys. 40 plus or minus 1.96. Sigma is 10 by 400. Okay. So this value I will get it to be 40 plus 1.96 by 4 is the right side. Okay. Okay. The left side value is this 40 plus 1.96 by 4 is the left side value. So this gives me 39.0 to 40.98. This is the confidence interval for the given value of, for the given mu sigma values. Okay, this is how I will write the confidence interval. This is how I'll calculate confidence interval if I'm being asked. Simple, guys. The question will be like find 95% confidence interval. Confidence interval would be the question. Okay. Find the 95% confidence interval. Means what? You will be taking like this. What? Z alpha. If it is two-tail, alpha by 2. Otherwise, it is Z alpha. Okay. Suppose if I am being given 98%, guys. 98% confidence interval if I am being asked. Then alpha will be 2%, guys. 0.02. Just see here how to find it. It's very easy once you understand how you're doing it. This is 0.02. This will be 0.48. Okay, guys. So I'll be looking for that value of Z. P of 0 less than Z less than Z1 will be 0.480 something in the table. You will see that I'll just tell you the value also from the table. Just a second. 0.480 value in the table would be 480 value would be 480 value would be 2.6. Z1 value would be 2, 2.56. I'm sorry. 2 point, what's it? 2.06 is the value as 2.06 is the value. So accordingly, I'll go for 2.06. So how I'll calculate x plus or minus 2.06 for the previous problem. 2.06 sigma by root n is my confidence interval. Mod I will put. Okay, a mod I can remove because I have put plus or minus. Okay, mod I'll put, then it'll be only plus. Accordingly, you'll be taking. I think I'm clear with confidence interval. It's very easy and simple, provided you know the formula for confidence interval. It tells me with how much confidence this value would be